Hello everyone. So today I'm going to share this little video about detailed steps of how to use the Gauss-Jordan elimination method. We are saying here in this example, we're going to do the Gauss-Jordan elimination method, which means we have to go all the way, right, until we get the identity on the left side, okay? If possible, until we get the identity on the left side. This is when we say Gauss-Jordan. Okay, so at first, we write the augmented matrix, which is, 2, -6, 4, 2, and then we have 3, -8, -1, 22, and finally we have -4, 13. And here, since we don't have z, so we want to put 0 and -30. Of course, these methods, they are not error or mistake tolerant, which means if you do one mistake, it's going to mess up the whole answer. If you do one mistake. All right, so hope we will not do any mistake. So this is our pivot right here. We take this one to be our pivot, and we like the pivot to be 1. The pivot need to become 1, right? So every time you need somebody to become 1, one of the ways to get that is to divide, especially here. In this case, look at the first row. Everybody is an even number. So why not divide by 2? If that was not the case, maybe we would have, looked at other ways to get 1. But since here everybody is an even number, so we divide row number 1 by 2. So, and every time you decide to do a step, you have to write down on your paper what the stuff is for the grader. This is a way for you to communicate what you're doing to the grader. If you don't write nothing, the grader does not know what you are doing. So it's going to take me a lot of time, long time to know what you are doing sometimes. And then if you do a mistake, then I will have no way to give you partial credit because I don't know exactly what you are doing. All right, so let's divide row number 1 by 2. See? And this goes quickly, 1 here, -3 here, 2 here, and then 1. Everybody was divided by 2, and then I just rewrite the other 2 rows. I advise you to write all the steps, On your test, I will grade all the steps. I will not, the final answer is important, but steps are also important. A good final answer cannot come from wrong steps. So believe me, I will look at the steps. If the step is wrong, and then at the end you have a good final answer, I will not give you the credit because something good, a good answer cannot come from wrong steps. All right. So now, who are our targets now in the column number 1? Column number 1, I want everybody here to become 0, right? Using the help of the pivot, right? This is my pivot, using the help of the pivot. So we go to our second step right here. So we just write the first row, 1, -3, 2, 1. This row is unchanged. Now we go to the second row. For the 3 to become 0, every time you want somebody to become 0, you have to enlist the help of another row. The help of another row is necessary if you want a coefficient to become 0. If you want the coefficient to become 1, the help of another row might not be necessary. You can just divide the row by a number. But if you want to get a 0, you must use another row, mainly the pivot row. All right, so basically what you're going to do. Of course, here, 1 and 3 don't make up to 0. So we need to multiply 1 by -3. You see, that's why I say -3 times row number 1 plus row number 2. And look at the way we wrote it down. The row that is not changed, the row that we're going to change right here. This is a changed row. That row is, we will not multiply it by nothing. This is how the algorithm works. The row we are trying to change, we don't multiply it by nothing. The other row, the pivot row, is multiplied by something. Okay? The pivot row is multiplied by something, but the row we are trying to change is not multiplied by nothing. So what you're going to do, you're going to multiply everybody by 3, of course. This is arithmetic. Everybody is multiplied by 3. 1 times 3 is 3. -3 times 3 is -9. 2 times 3 is 6. 1 times 3 is 3. All right, so we will do our best to avoid mistakes, okay? Because like I said, one mistake is still going to have a ripple effect on the final answer. All right, so we just add them up. What you get? We get, -3. You see, that's a -3. Everybody in the first row is multiplied by -3. I was saying, not 3. Everybody is multiplied by -3. So what you get? We get -3 here, +9, -6, and here -3. You see, I was talking about mistakes, and then I was about to do a mistake, right? But it's okay. So we add them up. 3 plus -3 is 0, right? 9 plus -8 is 1. And that's a good number to get 1 here. We're going to see it in a minute. -6 plus -1 is -7. And then -3 plus 22 is 19. Right? Okay, so now we focus on the -4. We want -4 to become 0. Enlisting the help of row number 1 again. So, but here we're going to multiply everybody in the row number 1 by the opposite of -4. We're going to multiply everybody by on the pivot row by the opposite of -4, which is +4. It's going to be 4R1 plus R3. Look at, they are similar. The row that is change again, we don't multiply this row by nothing. The row we try to change, we don't multiply by nothing. Is the pivot row that we multiply by something, right? And then everybody is multiplied by 4. 1 times 4 is 4. -3 times 4 is -12. 2 times 4 is 8. 1 times 4 is 4. And then we just add them up. So what you're going to get? You're going to get 0 here. 4 plus -4. And see what you want it. -12 plus 13 is 1 again, right? And 8 plus 0 is 8, right? And then 4 plus -30 is -26. This example is a nice example. I wonder why, the numbers are nice like that. Maybe I chose them for our first example to be a nice example like that. Now we are done with column number 1. We move to the column number 2, where this one is my pivot now. I'm going to use this pivot to make this one become a 0. As you can see here, is almost automatic, right? So we have 1 here. So we write this pivot row. We don't change it. All right. So now what you're going to do? We're going to say, right? We're going to say row number 2, we're going to multiply by the opposite of this one here. It's going to be -1 times row number 2 plus row number 3. You see? -1, which is the opposite of 1 here, times row number 2 plus row number 3. What you're going to get? You're going to get, everybody here is multiplied by -1. It's going to be 0 right here, -1, +7, -19, right? And then we add them up. 0 plus 0 is 0. -1 plus 1 is 0. And 7 plus 8 is 15. And -19 plus -26 is -45. Lucky. Why I say lucky? Because now my stuff is my new pivot right here is to become 1. Remember, we want to get the identity at the end of our process. And I say lucky because -45 happens to divide nicely, to be divisible nicely by 15. So of course, to make 15 become 1, we're going to divide row number 3. We're going to divide row number 3 by 15. I have 1, -3, 2, 1, and here 0, 1, -7, 19. And here, row number 3 divided by 15. You see, I communicate everything that I am doing. Okay, of course, here 0, 0. Everybody, 0 divided by 15 is 0. 15 divided by 15 is 1. This is our pivot. And -45 divided by 15 is -3. The beauty of the Gauss-Jordan elimination method is the Gauss method, if you do it correctly, when you gain a nice coefficient like 0 or 1, you will not lose them. You will not lose what you gained. This is the beauty of the method, right? Okay, now, this is my pivot now. Who are my target? Now I go the other way around now. These two need to become 0, and the next 7 needs to become 0. Using what? Using the pivot row number 3. This one right here. What am I going to do? I'm going to do what you did so far. So basically, I'm going to multiply row number 3 by the opposite of 2, which is -2. So -2 row number 3 plus row number 1. You see, the row we are changing again and again. The row we are changing, we are not multiplying this row by nothing. All right, so my pivot row, I write it down. I'm not changing it. But everybody here is multiplied by -2. So again, if I wanted to see it better, I can write in small numbers like 0 times negative is 0, 0 times -2 is 0, 1 times -2 is -2, and -3 times -2 is +6, right? I just add them up. I just add this right here, this new, this row, small writings, because I don't want to make it big writings. I don't want to make it big writing, so I don't conflate between a true row and a row. I don't want to do this. Because if I do this right here, I might confuse this row with a true row. It is not a true row. It's just something I use for my calculation. So per habit, I write it like small. If I do write it down, it's 0, 0, -2, +6. I just add it to the first row. Of course, 1 plus 0 is 1. -3 plus 0 is -3. -2 plus 2 is 0. This is what you wanted, right? And 6, no, and 6 plus 1 is 7, right? Okay, now my -7 need to become 0. What I do? I'm going to multiply the row number 3 again by +7, 7 R3 plus R2. You see, again, all the steps, they look alike. A Gauss elimination is just a repeat of the same steps, pretty much. So basically now I'm going to multiply row number 3 by +7. So which is 0 times 0 here, 0 here, 7 here, -21. And then I'm going to add it to the row number 2. Again, 0 plus 0 is 0, 1 plus 0 is 1, and then -7 plus 7 is 0, and 19 plus -21 is -2. You see? Now, this become my pivot because my last target is this one to become a 0. And that will be our last step. All right, so for that, then I have row number 3. I'm done with it. 0, 0, 1, -3. Row number 2 is a pivot row right now. I don't change it. Okay, now row number 1, of course. To make this -3 become 0, I must use this one right here. It's my new pivot. What I'm going to do? I'm going to multiply the pivot row, which is row number 2, by the opposite of -3. I said 3 row number 2 plus row number 1. So everybody here is multiplied by 3, 0, 3, 0, -6, and then I add it to the first row. 1 plus 0 is 1, right? 1 plus 0 is 1. -3 plus 3 is 0. 0 plus 0 is 0, right? And finally, 7 plus -6 is 1. You see, this is a Gauss-Jordan. Gauss-Jordan, this has to be the identity if possible, right? If possible, this has to be the identity if possible. Now I'm done because how I'm going to use the answer? The first column is a column of the x's. The second column is a column of the y's. The third column is a column of the z's. So basically what this gives me then, the solution is x equal 1, y equal -2, and z equal -3. So basically, I have a unique solution, one solution, 1, -2, -3, right? That is my solution. So in my next video, which I will post, in the near future, I will give you an example where we have infinity many solutions, where we have parametric solutions. All right. Thank you very much.